Do you like to get wondered every day? Or have you ever thought of being disappeared somewhere and appear somewhere else? Then quantum mechanics is exactly for you. Quantum mechanics actually describes the behavior of particles of very small scale. The wonder of quantum mechanics starts with the wave-particle duality. But the question here is, what is the wonder in it and why it is so important? For that, we have to understand wave-particle duality. And to understand wave-particle duality, we have to do an experiment called the double slit experiment. For this, we'll need a screen. We'll throw some electrons to the screen. We'll have a wall in the middle. The electron can pass through these two slits to. Before doing this, let's think about an electron. What is it? Is it a wave or a particle? If it is a particle, it should just act like this ball. When you throw this ball, either it goes through this slit or this slit, and on the screen, it only hits around these 2 points and makes a pattern like this. But if electron is a wave, it should act like a water wave. Water wave simply goes ahead like this, passes through both slits, it makes two new waves, they interact with each other, and some parts of the wave become disappear. This happens for a property of wave called interference. When two waves from the same source with opposite phase interact with each other becomes disappeared. So some parts of the wave become disappeared and it makes a pattern like this on the screen. When we threw some electrons, something wonderful happened. The electrons hits almost all over the screens and makes exactly the same pattern like the water wave. But it is not really like a water wave, it's a wave probability function by which we can predict that where the electron is probably going to hit. So electron is not just a particle but also a wave. Actually all the small particles in our universe behaves like wave. Wait. Everything we see and even our body are made of these small particles. So why don't we behave like wave? For that we have to understand the relation between momentum and wavelength. Let's think about a photon. We cannot calculate its momentum in classical mechanics. But in quantum mechanics, we can calculate its momentum by de Broglie's equation P equal to h divided by lambda. It means smaller the wavelength and the more momentum it has. Our body has much more momentum, so our wavelength is very small, smaller than the Planck's constant. And when the wavelength of a particle becomes smaller than Planck's constant, it no more behaves like a wave. This is quantum mechanics. When particles are not only particles but also wave, then many things happen that we cannot even think of. Like the quantum leap, disappearing somewhere and appearing somewhere else, or the entanglement, two particles connected with a mysterious connection, and many more laws that works like magic. We cannot do this because our wavelength is very small, but the particles everything is made of are doing these magical things every moment. So quantum mechanics is a wonderful theory that describes the wonderful behavior of particles everything is made of.